Welcome back for properties of the definite integral. Let's get started. First of all, remember that this definite integral was the limit as all the delta x's went to 0 of this Riemann sum. And the Riemann sum was the sum from j equals 1 to n of f of your sample points times your delta x's. Now, since we know that sums split up nicely like this, and because constants pull out of sums in the same way, the properties of the integral will be very similar to the properties of the sum, because the limit also behaves well with respect to sums and constants pulling out. So it's easy to show that, in fact, the integral from a to b of f of x plus g of x, a sum of functions, splits up as a sum. So is the integral from a to b, f of x dx, plus the integral from a to b of g of x dx. In other words, the integral of a sum is the sum of the integrals. And similarly, for constants from a to b, a constant times a function, that pulls outside of the integral sign. Bear in mind, this is constants only. Nothing else pulls outside of the integral sign, only constants. Okay? All right, well, just knowing these two things allows us to do much more complicated examples. For example, the integral from 3 to 4 of 1/2 x squared. Let's not do 1/2. Let's just do x squared plus 3x plus 5 dx. Well, to break this up, so this will be the integral from 3 to 4 of x squared dx plus the integral from 3 to 4 of 3x dx plus the integral from 3 to 4 of 5 dx. And then, let's just leave this one alone for now. We can pull out this constant 3 here. So it's 3 times the integral from 3 to 4 of x. We can pull out the constant 5. 5 times the integral from 3 to 4 of 1 dx. And then we knew how to do this integral. It was 1/3 4 cubed minus 1/3 3 cubed, or at least we claimed the formula worked. And here it was 1/2 4 squared minus 1/2 3 squared. And then here it was 5 times 4 minus 3. And so now you can do the integral. All right, there is one more property, and it's really summarized by this picture here. If you wanted to figure out the area from A to C, and you had a point B in the middle, you could first do this area, and then secondly do this area, and add them together. And because of that, you get another property of the integrals that says the integral from A to C of f of x dx will be the integral from A to B, f of x dx, plus the integral from B to C, f of x dx. And then finally, one last rule, which is hardly worth mentioning. If you integrate from a to a of anything, you get 0 because there's no area. All right, that's it for properties of the integral. See ya.